Hi everyone, today we're going to get started with the third day of our Java programming course. Today we're going to be going over some of the more complex concepts. More specifically, we're going to be talking about changing the flow. And that's a really big concept, so before we get started, I just want to briefly explain what that means. So this idea of changing the flow is that instead of having programs that only have one path, we're going to make programs that have several paths. And by the end of today, we're going to be making a complex game that is really similar to the adventure games that were made back in the 1990s. So with that said, let's get started. We're going to be doing some of the homework review first. So if you remember from last class, we were working on a report card project. If you haven't finished that yet, please finish it in the next 5 to 10 minutes. And if you've already finished that, then work on these 5 problems. For those 5 problems, what we want you to do is try seeing if you can predict what those problems would give you if you put them into Eclipse. For example, for the first one, 103 plus 158. If you put that into Eclipse, that would probably give you something like 261. So try doing that for the rest of the other 4. And then if you finish with those 5, finish the temperature converter and the leap year that were assigned for homework. Alright, great. I think most of you finished the report card by now. If you haven't, then and you still have any questions, you can ask Nikhil or I anytime during the class. But let's talk about some of these 5 problems that we've assigned you. So I already mentioned the answer to the first one, 103 plus 158. That's just really simple. It's straightforward addition. But let's go to this next one. It's 103 in quotation marks plus 4. So does anyone have any idea of what that might be? Yeah, so this one's a little more complex. In reality, the answer is actually 103 plus 4 becomes 1034 because we have quotation marks, which means it's a string. It's not just a normal number. The next one's also pretty complex. We have 6 divided by 5. And if you do that normally on a calculator, you're probably going to get like 1.2 something. But if you do it in Java, you're actually only going to get 1. And the reason for that is, as we mentioned last class, Java is going to round down if you're doing an operation on 2 integers. It's not going to give you a decimal point, it's just going to give you an integer. So if you divide 6 divided by 5, that's going to give you 1.2, but Java is going to round that down to an integer, which is going to give you 1. Next we have 5% 3, and if you remember, percent is the remainder symbol, so that's going to give us 2. And then the final operation is pretty complex. There's 2 parts and they're separated by an and that means that both of them have to be true for the overall thing to be true. And if anything else happens, then it's going to be false. So let's look at the first part. Is 5 equal to 5? Yeah, that's true. So the first part is true, and then the second part is also pretty complex. We have, is 4 not equal to 2? So since 4 is not equal to 2, that's going to become true, which is going to make the whole second part true, which is going to make the entire statement true. So the answer to the 5th part is actually true. Okay, so now let's move on to some of the flow concepts. So far all of the programs we've done have only had one path. Sure, there's been some input and output, but really there's only one thing that can happen in your program. And so now we're going to be working on programs that can have different paths, that can go in different directions based on some data or based on something the user inputs. So for example, let's look at this flowchart to the right. Let's say we have a lamp and it doesn't work. There can be 2 reasons why it doesn't work. A, it's not plugged in, or B, the light bulb on the lamp actually doesn't work itself. So if we wanted to troubleshoot this lamp, then what we'd do is we would check A, is the lamp plugged in? And if it's not, then we would plug in the lamp and we would repeat. And if it is plugged in, then we would check if the bulb is burned out. And if it is, then we would replace the bulb, otherwise we would buy a new lamp because we weren't able to fix it. So just like that, we can make our Java programs take different paths. So now let's look at some more of these flowcharts so that we can try and write out on pieces of paper what our Java programs are going to do in a form that's going to make it easy for us to understand how we make these paths and how the computer is going to make these decisions. So for example, let's look at this flowchart on the left. This is an example of one of the flowcharts we've been doing in the past where you just have one thing that can happen in the program. There's only one thing that can happen overall. So on the flowchart on the left, we would go to the start. The program's going to declare these 3 variables, num1, num2, and sum. It's going to read in num1 and num2 from the user, that's input. And then sum is going to be assigned the value of a plus b. That's actually supposed to be num1 plus num2. It's going to display sum, and then it's going to stop. So what this program just does is it takes in 2 numbers calculates the sum and outputs it to the user. So that one is pretty simple. We can actually make that program ourselves with the current knowledge we have in Java. The one on the right is a lot more complex though. If we look at there's so many arrows, so it's hard to imagine what's happening. So one way we can approach this problem is try giving it some, going to the start and then try giving it some bogus values. So try using that strategy and see, take the next couple of minutes or so and see if you can understand what the flowchart on the right is doing. Okay, so now let's discuss the flowchart on the right. So we're going to go to the start condition, and then from there, there's an arrow that points down to read G. So we're going to go to read G. And so what read G means is that we're going to take the value of G, and we're going to get it from the user. So that's just the standard input that we've been doing all this time. Next, we have this if statement. So it says if G equals N. So that means if G and N have the same value, then we do something, otherwise we do something else. That's just the exact same thing as if the lamp is plugged in, then we either plug it in or we check if the bulb is burned out. So except in this case, if G equals N, then we say true. So if G does equal N, then we're going to print done, and we're going to end the program. Otherwise, if G is not equal to N, then we check if G is greater than N. And if it's not, then it's too small, and we go back to the start. And if it's not, then it's too big, so we go back to the start. So let's take some sample values. Let's say we read G and the user says G is 10. And let's just say N is 50. So is 10 equal to 50? No, it's not, so we go down here. Is 10 greater than 50? No, it's not, so we go down here. We print too small and we repeat. And now let's say the user decides to pick G as 100. Is 100 equal to 50? No, it's not. Is 100 greater than 50? Yeah, it is. So we would go to print out too big, and then we would start over. And now let's say this time the user inputs 50 as G. So is 50 equal to 50? Yeah. So we would print done and we would end the program. So you could describe the flowchart on the right as some kind of guessing game, because the user inputs a guess G and compares that to a number N. So now, these past two problems have been, we give you a flowchart and you decide what the code does. Now what we want you to do is, we're going to tell you what the code does and we want you to make a flowchart. So take the next 10 minutes or so and try to make flowcharts for both of these problems. The second one is pretty complicated, so focus on finishing the first one. I can cut this out. Alright, so now let's go over the flowchart on the top, the first one. So the problem is asking, create a flowchart that describes how you would process a check in the bank. If the person has enough money in their account, you should give them the money, otherwise you should bounce the check. So we might start off with a start statement, and then go into one that says read check, or read the amount the user wants to withdraw. From there we would want to compare it to the amount that they have in their bank, and we could say something like, if amount withdraw is equal to amount if amount withdraw is greater than amount in bank, then we would need to throw an error and tell them and bounce the check because they don't have enough money. Otherwise, we can give them the money. So that only has two paths, and that's a little more simple than the second example. So the second example is a challenge for you. If you finished it, then raise your hand and Nikhil can go around and he can tell you if you got it right, and if you didn't, he can give you some pointers. Alright, so let's now move on to the concept of how we're going to implement this in Java. So this is just a brief illustration of some of the control statements that Java has. There's if else, for, while, switch, break, and continue. And some of these are pretty complex. Today we're only going to be working on if else, and switch. So like I mentioned before, if and if else allows the program to select different paths of execution. So that's, in our flowcharts, that's basically the if statement. That just lets you take two different branches. And the switch statement is something that's very similar, except it's used when you have several different branches. So let's go into detail about the if statement and the if else statement. So the syntax of the if statement in Java is if, open parentheses, the condition is met, close parentheses. Then we're going to do some code. And that, remember, in Java, we need to surround blocks of code with these curly braces. So we're going to say if condition is met, curly brace, then we're going to have some code, and we're going to close it with another a closing curly brace. So for example, for this robot illustration, if robot has hit wall, then curly brace, then we could say like robot should go back, end the statement. And this condition met should always be a boolean. So if you remember our conditional operators from before, those give us booleans. So oftentimes we're going to put those conditional operators inside the if statements. Now the statement on the left is pretty similar, except now we have if condition met, we're going to do something, else the condition was not met, so we're going to do something else. And in this case, we're going to have our braces closing the first code block, and we're going to have new braces opening the second code block for the else statement. So if we wanted to ask a friend if we wanted to wish a friend happy birthday, happy early birthday, or happy late birthday, depending on when his birthday is, then we could use code blocks like this. So if his friend's birthday is today, say for example both those variables are integers, then this is going to give us a boolean that's either true or false. If it's true, we're going to print out happy birthday because it's his birthday today. Otherwise, we're going to check if it's the friend's birthday is greater than today, which means that his friend's birthday is sometime in the future, in which case we're going to print out happy early birthday. Otherwise, the friend's birthday must be less than today, so it's already happened, so we're going to print out happy late birthday. And that's the same thing as down here, except we just have it separated out. Here, it's the exact same thing. So we have one code block determining if the friend's birthday is today, one code block determining if the friend's birthday is after today, and one that is the default, that if none of the previous ones are true, then we're going to go to the else statement. Okay, so now let's work on the switch break idea. So let's say, for example, you have a variable and it can have several different values. Like you have a day, and the day can be either Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. So if you wanted to compare all those different values to the value of the variable, you would do, using an if-else statement, you do something like if day equals Monday, else if day equals Tuesday, else if day equals Wednesday. And you'd have to keep doing that for Monday, Tuesday, Wednesday, Thursday, Friday, all the way down to Sunday, which is really annoying. So that's what these switch break statements were made for. So let's take our day example. Let's say we wanted to compare the value of day to the numbers 1 to 7, where 1 corresponds to Monday, 2 corresponds to Tuesday, and 7 all the way up to 7, which corresponds to Sunday. Then the syntax is like this. We would say switch, open parentheses, the name of the variable, which in this case is day, close parentheses, and then since it's the code block, we need our curly braces, one that opens and one that closes. And now we're gonna write down the different cases, the different branches of our program. So for example, we can have case 1 where day equals 1, case 2 where day equals 2, case 3 where day equals 3, case 4 where day equals 4, case 5 where day equals 5, or anything else which is default. So let's go through the program using an example for day. So let's say for example day equals 2. What the program would do, it would go case 1. Is 2 equal to 1? No. Is 2 equal to 2? Yes. So because 2 is equal to 2, it's going to do case 2, and then it's going to do everything after that. So it's going to do case 2, which is nothing. It's going to do case 3, which is nothing, case 4, which is nothing, and case 5, which is nothing, or which is something. And in case 5, we print out that it's a weekday, and then we have this break statement, which is going to take us outside of this curly brace. So as soon as we hit this curly brace, we're going to exit the switch statement and go to whatever code is below that. So if the day is 1, we're going to do case 1, case 2, case 3, case 4, case 5. We're going to print out it's a weekday, and then we're going to hit this break. If the day was 0, we would go, is 0 equal to 1? No. 0 equal to 2? No. 0 equal to 3? No. 0 equal to 4? No. 0 equal to 5? No. Default. So the default will happen if it hasn't hit any of the cases before, or it hasn't hit any of the breaks before. So default, we would print out it's a weekend, and then we would exit out of the switch. So this is a lot less code on the left than using the code on the right using an if-else statement. On the left, all we have to do is, for the 5 different cases, we only need 1 line of code, and then for everything else, we only need 1 line of code. Whereas for the one on the right, we need to print out weekday in 5 different places, and that's a lot of repetition. So now, for our game, the Dungeons and Dragons game that we're going to be working on at the end of class, we're going to work on the concept called random numbers. So in computer science, random numbers have been notoriously difficult to produce. There's all these different concepts and algorithms to make them, but Java's made it really simple for us so that we can do this with only a few lines of code. So let's open up Eclipse and create a new class, file, new class, and let's call it random numbers. And make sure you check public static void main, and then click finish. So now the first thing we want to do is generate a random number that's, let's say for example we want to do a dice roll. So the first number we're going to generate is this thing called math.random. So let's just see what that gives us. Double random number 1 is math.random. And then let's print out the value of random number 1. And then click the run button. And that's going to give us 0.515. So keep clicking the run button and see if you can find the minimum value of random number 1 and the maximum value. Okay, so far I found that the smallest value I got was 0.04 and the largest value I got was 0.7. So that means that the random number 1 is probably going to be between 0 and 1. And that's actually true. Random number 1 is always going to be between 0 and 1. So let's write that in our code. And now let's think. We want to make this a dice roll. And dice rolls are usually from 1 to 6. So let's move on to the next step. Here we have double random number 2 is equal to random number 1 times 6. So let's type that into Eclipse and see what that does. Okay. So now the smallest number I got was around 0.05, and the largest number I got was around 5. And that kind of makes sense. If we have numbers that are between 0 and 1, and we multiply that by 6, now we're going to get numbers that are between 0 and 6. Now let's go to the third step. So these are all decimal numbers, but dice rolls can only be integers. So what we're going to do is we're going to convert random number 2 to an integer. Make sure you don't spell it wrong like I did. Alright, and then we're going to print that out. And let's see what that gives us. So you can see that with random number 3, we're always going to get the integer that is less than random number 2, but is closest. So for example, if we had 3.5, it would give us 3. If we had 4.99, it would give us 4. So now this can be 0, 1, 2, 3, 4, or 5. And it can't be 6 because before it was everything between 0 and 6. So that could give us all the way up to 5.99. But that's going to round down to 5. And then the final step is to convert this from 1 to 6. And right now we have 0 to 5, so we can just add 1. So let's see what this gives us. 5, 4, 1, 5, 1, 6. Yeah, so now we're getting random numbers from 1 to 6, which is perfect for our dice roll. Now that's a lot of code to make a random number, so you can actually do all of that in just one line. And this is what it looks like. We're going to do math.random, we're going to multiply it by 6, we're going to convert that to an integer, and then we're going to add 1. And let's print that out to make sure that it's working as it should. Three, 6, 1, 4, 3. Yeah, that looks right to me. So that's how you get random numbers. Alright, now that we've finished random numbers, let's go on to the exciting part of the class with Dungeons and Dragons. So the point of Dungeons and Dragons is to make an adventure game where with using if-else statements. So for example, we can have the user start out in like a dark and dreary corner of some kingdom, and they can always have two choices. And then based on what they do in those choices, they can either die or they can continue playing. And eventually they can either win the game or they can die. So let's get started and make a class file, new class. Let's call it Dungeons and Dragons. And make sure you click public static void main, and then click finish. Alright, so now the first thing we want to add is the input output code. If you don't remember how to do that, you can just use the input output class that we made before. But if you do, then just type it in. So the first thing we want to do is import java.util.scanner. That's going to give us the default Java library that we can use for input output, or actually just input. Then we're going to make our input object. Alright, so now let's print out a starting message to the user. Any ideas?
Well, I guess we can start off by saying, how are you doing? Do you want to play a game?
Alright, yeah, let's start off with that. How are you doing? Question mark. Do you want to play a game? Okay. So now we can either have two choices for that. Yes or no. So let's say yes, no. Now we want to be able to get the input that the user enters. Does anyone remember how to do that?
Well, yeah, we can use a scanner.
Yeah. So using our scanner, we can actually use the method input.nextLine. So let's do string answer equals input.nextLine. And remember, that answer can either be yes or no. So if we want to check what the value of answer is, we can do answer dot equals yes, answer dot equals no. So notice that this is different than just doing answer equals yes, and that's because these are strings. If you remember before, then strings are complex objects. You can tell that because they're capitalized, which means you can't just do the double equal sign, you have to do dot equals. So now if we want to put this into our if statement, answer dot equals yes is going to give us a boolean, so we can just put parentheses around that. Right, if, and then put our code block using curly braces. And it can either be yes or it can be anything else, so we're going to put an else statement. So if the answer is yes, then we're going to want to keep asking more questions and continuing the game. Otherwise, we're going to print out something like I guess you didn't want to play my amazing game. Your loss. So now let's start running the program. How are you doing? Do you want to play a game? If I put no, it's going to say that I didn't want to play the game. If I say yes, nothing's going to happen because we don't have any code here yet. So now let's add some code there. Now that the user's already decided to play the game, let's think about where we want the user to start. Do you guys have any ideas of where the user should be? Where should the game start?
Let's start inside school.
Yeah, I agree. School's a really dangerous and creepy place.
Yeah.
It's going to be perfect for a Dungeons & Dragons game. So let's say you are, for some reason, at school in the middle of the night. You hear some creepy noises. but you can't see anything. And now we give the user a decision. So let's ask them, what do you do? And now let's give them two choices. You can either run, or you can either, what's the other option? Let's say investigate. You can either run or you can investigate the noises. So now we're going to want to get answer again. And so we're going to do answer equals input dot next line. And now we're going to have another if statement. If answer dot equals run, we're going to do something, else we're going to do something else. So which one do you want to make the user die for, run or investigate? Because we can only have one thing that allows the user to win.
Let's make them die if they run.
Alright, so the user dies if they run. So now we have to tell the user that they died, because they made the bad decision to run. Does anyone have any interesting ideas for death scenes?
I don't know. Maybe they trip over a book and hit their head.
Alright, yeah, that sounds good. You try running away from the creepy noises, but you suddenly trip over a book and hit your head. You can't see anything, and suddenly you are attacked. Let's say you're attacked by a vicious book. The vicious book. Unfortunately, you lose. And then we can say something like system.out.println, game over. Alright, so now let's try playing the game. How are you doing? Do you want to play a game? If I say no, it's going to say that I didn't want to play the game like it did before. But if I say yes, then let's see. You're for some reason at school in the middle of the night. You can hear some creepy noises, but you can't see anything. What do? You can either run or you can investigate. So if I run, it's going to say that I died, and it's going to say game over. But if I investigate, then it's going to do nothing, because we still don't have code there. So you can keep continuing that until you get to a situation where you can make the user win. So I'm going to just show you how to do that quickly. I'm just going to make it so that if you investigate, you win, but you can add more layers of complexity to your game using more if statements. You investigate the disturbance and notice that there is an evil book lurking in the corner. You feed it, become best friends with it, and win the game. And I can say something like system.out.println, you win, game over. So now we have a fully functional game. I can play it, I can die, I can play it, I can win, and I can decide to not play it. Yeah, so there's definitely a lot more that you can do with this game. Like, you can have more stuff inside of the investigate, like have weapons. You can add all kinds of functionality. So why don't you guys take the rest of the class and work on building upon your Dungeons and Dragons game. Try adding more complexity to it. And if you have any really interesting ideas, why don't you share them with the class? Alright, great. Your Dungeons and Dragons games look really interesting. So that's all for today. We've covered a lot about if statements and switch statements. And next week we're going to be working on some more of the flow control statements, like for, while, break, and continue. And Yeah, I hope you enjoyed today's class. Thank you for coming.